All right, ladies and gentlemen, this is the 1-1 and 1-2 instructional video. Before you continue with this lesson, make sure you have your Chapter 1 packet, a writing utensil, a ruler, and a calculator. Make sure you write your name in bold marker or something that's not going to erase on the cover of your packet so that you don't lose it. This packet is due at the end of the unit and will be collected. I don't have any extra copies of the packet. You're going to want to make sure that you keep it in a safe place and you're nice and organized. All right, press pause until these materials are on your desk. All right, here's your learning target for today. There's 3 big things that we're going to do. First, you're going to learn how to identify the type of function family a graph belongs to. We're going to explore 2 function families today. You're also going to describe the graphical characteristics of a graph and create a graph to represent a scenario. All right. On the inside cover of your Chapter 1 packet, I want you to write down the definition of a function. So go ahead and press pause and copy the definition in the 2 sentences that are on the screen. Okay, so just to read it to you, a relation is a function if each input has exactly and only one output. One way to determine if a relation is a function is if it passes the vertical line test. Okay, I'm going to share with you 2 examples of a vertical line test. Go ahead and jot these in your notes or on that front cover along with the definition. Okay, so right here you can see I have a line and I have a circle. So I have 2 graphs. And over here to the right, I have this red vertical line. Okay, so it passes the vertical line test if, so this line, this blue line, passes the vertical line test if no matter where I put the red line, it only touches the blue line once. So you can see wherever I put this, it never touches the graph in more than one spot. All right, so that means this is a function. And it's a function because it passes the vertical line test. Okay, so let's look at the circle. If I put this vertical line on the circle, you can see that it touches the circle in 2 spots, right here and right here. That means this is not a function because it doesn't pass the vertical line test. The vertical line test says the vertical line can only touch the graph in one spot. What this means is that one input on the circle has more than one output. Okay, here's a reminder. When we're graphing, because one of our jobs today is to graph, and you can go ahead and jot this down on the inside cover of your Chapter 1 packet, is the x-axis, is the horizontal axis here. This is the independent variable or the independent quantity. Okay, the y-axis is the dependent variable. So this is going to be really important when we start to graph. Okay, we need to talk about function families. So there's 2 that we're going to talk about today in this video. The first is a linear function family. A linear function family, or a function is linear if it's a straight line. So just think of a straight line similar to this example right here. This is a straight line, so it belongs to the linear function family. Exponential functions are a curved line, but not any curved line. They need to look like this. So to me, they kind of look like half of a U, or they might go in this direction. And that one's kind of light, but hopefully you can see it. Or maybe they're flipped upside down, but they're a U-shape curve, but only half of it. All right, so go ahead and continue jotting this on the inside cover. Press pause so you can get all of this jotted down in your Chapter 1 packet. Okay, so you should be familiar with increasing functions and decreasing functions. So increasing functions have a positive slope and they go up from left to right. Decreasing have negative slopes and they go down from left to right. Here are 2 new vocab terms. Continuous. A graph is continuous if the points in the graph are connected and if the units can be fractions. We'll talk a little bit more about this in an example, but write this in your notes, even if it's not totally clear right now. A discrete function is a graph that could have dots that are not connected and the units cannot be fractions. So think of some real life things in life that can't be represented with a fraction. So if we are graphing some information about puppies or children, those kind of things are examples of things that can't be real life represented by a fraction. So those would most likely be graphs that are considered discrete. All right, ladies and gentlemen, go ahead and find this page in your chapter 1 packet. I'm going to model for you all the work that's going to be expected on your next practice problem that you'll do by yourself and on your homework. Okay, so I'm looking at the directions, and the directions up here say, create a list of important information from the scenario. All right, so what I'm going to do right here is I'm going to highlight some important information. Got my highlighter ready. I'm going to read this problem. Candace is a building manager for the Crawley Enterprise office building. One of her responsibilities is cleaning the office's building 200-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 10 gallons per minute. Okay, so what I'm thinking to myself is I think it's important to know that the aquarium is 200 gallons. I think that's important. I'm going to switch to my highlighter here. That might make it a little easier. All right. I also think it's important to know that I'm draining the water. That means water is leaving the aquarium, which means it's going down. And then I also think it's important to know that it's being drained at a constant rate of 10 gallons per minute. So that's the information that I think is important. Okay, so what I need to do next now is I need to create a graph. But to do that, I have to figure out what the independent and dependent quantities are. So what that means is I need to figure out what's going to be on my x-axis and y-axis. And here is a tip that I have for you. Go to the rate. I'm going to find the rate, which is 10 gallons a minute. I'm going to try to write this on my computer here. This is going to look bad. 10 gallons per minute. Okay, so what you need to know is the first quantity, the gallons. Oh, look at that. Gallons is going to be represented with the dependent quantity. So gallons, the first unit, gallons right here in my rate, is going to go on the y-axis. Minutes, that switched it to MN, sorry about that. Minutes is going on the x-axis. So when you look at a rate, the first unit is always the the dependent unit. The second unit is always the independent unit. So what I'm going to do right now is I'm going to go ahead, I'm going to grab my pen, and I'm going to plot the gallons on the y-axis, and I'm going to plot the minutes on the x-axis. Okay, so it's a little reversed from an ordered pair. That's okay. All right. I'm going to set up an XY table right now. And I'm going to try to do that by typing. So give me a second, be patient here. So an XY table is going to look like this. And I'm going to get my lines in there. I want you to write this on your paper with me. Okay. So my X unit is my minutes and my Y unit is my gallons. This is what I need to ask myself. When Candace starts at time 0, I need to ask myself how much water, how many gallons are in the aquarium? Well, she didn't clean it yet, so there's 200 gallons in the aquarium. So my first ordered pair of my table is 0, 200. Okay, after 1 minute, there are 190 gallons in the aquarium because Candace is draining the aquarium at 10 gallons per minute. After 2 minutes of cleaning the aquarium, Candace has 180 gallons in that gigantic aquarium. Oops, sorry. After 3 minutes, Candace has 170 gallons in the aquarium. Okay. Sorry about my technology here. So what I need to do right now is I need to set up my graph so these 4 ordered pairs, and typically the rule of thumb is you want to get 3 or 4 ordered pairs on your graph. Okay, so what I'm going to do is I'm going to press pause on my video. I'm going to ask you to do exactly the same. I want you to label your x-axis in minutes, your y-axis in gallons, and I want you to plot these 4 ordered pairs. All right, press pause and complete your graph. Okay, here's my graph. I want to point out a couple of things to you. I put time on the x-axis because we determined that was the independent quantity and it was the x value. We put water remaining or gallons on the y-axis because that's the dependent value. So the amount of water remaining depends on how much time I was draining the aquarium. I also want to point out I have a title. And then what I went ahead and did was I took those ordered pairs, sorry about that were in the table, so 0, 200, and I plotted them. So 0, 200 is here, 1, 190 is here, 2, 180 is here, and you can kind of see my pattern. So this is my graph. So what my graph looks like, I connected those points with a ruler. All right, underneath this scenario in this graph, I want you to write down the words graphical characteristics. Okay, here's the first one. This passes the vertical line test. So what that means is this is a function. Okay, what kind of function is it? It's a linear function because you guys just took notes. If it's a straight line, it's a linear function. All right, this is a continuous function because if I scroll back up here, time can be represented in fractional units and same with gallons. So because both those units can be fractions, it's continuous, which is why I connected the points. And lastly, it's a decreasing function. So on any summative assessment, you would be expected to use the vertical line test to determine if something's a function. Tell me the function family, tell me if it's continuous or discrete, and tell me if it's an increasing, decreasing, or constant function. We'll talk about constant in class a little bit later. All right, ladies and gentlemen, here is your next job. Now that we ran through that example together, I want you to go ahead and turn the page, complete scenario 2. It's called a smartphone, but is it a smart deal? I want you to do exactly what we just did in the last example. I want you to create a list of important information, graph it, answer the couple questions that are at the end of the scenario, but most importantly, because this is the brand new stuff, I want you guys to write down all the graphical characteristics that you see in that graph. Go ahead and press pause to complete a smartphone, but is it a smart deal? All right, you guys, now that you completed a smartphone, but is it a smart deal? We'll check that in during our next class. Make sure you got all those graphical characteristics. Your homework for tonight is to complete the 1.1 and 1.2 homework sheet. It's in your chapter 1 packet. So flip a few pages, and at the top it's labeled IM9 sections 1.1 and 1.2 homework. A couple of things I want to point out, you guys. There's 4 scenarios. Each scenario has 6 questions to it. So look where it says underneath your name for each of the following scenarios. There's 6 things you need to do. The good news is you don't have to create any graphs, but you do need to be able to describe them using graphical characteristics. All right, ladies and gentlemen, that's your homework. Good luck.